So because of the workout which I started yesterday, because of that my health was a little bit down yesterday. Okay, so I began to exercise once again after quite a long time. So that's why there was muscle ache in my body yesterday. So that's why I couldn't take the class. Really sorry for that. But we will start from here. That is total force equation of motion in a non-inertial frame. Okay. So let us suppose that A is your acceleration of a particle in an inertial frame S. Okay, let me put this to the side. Sure. So total force equation of motion in a non-inertial frame. Then what is a non-inertial frame? You have already seen, right? An accelerating frame is a non-inertial frame as shown over here. You must have learnt in the previous class as well that this S prime or S dash, whatever you can call it. So you can call it S prime also or S dash also. I will call it S prime over here. So this S prime, it is moving with a constant acceleration. So such an accelerated frame is called as non-inertial frame. Okay. So total force or equation of motion in a non-inertial frame. But which kind of non-inertial frame? Okay, which kind of non-inertial frame? Moving with a constant acceleration. This thing also you must remember. Okay, what kind of non-inertial frame? A type of non-inertial frame in which acceleration is constant. Okay, if the acceleration is not constant, then certainly the situation becomes complex. Okay, if acceleration is not constant, then the situation becomes complicated, right? So in order to simplify our situation, we are writing the equation of motion of a non-inertial frame, but such a non-inertial frame in which acceleration is constant. Okay, so let me explain what is acceleration is constant. This vehicle is moving in the right side with constant acceleration a naught. But suppose if the acceleration is not constant, then what will happen? The equation of kinematics you cannot apply. Suppose this a naught changes in at every point. Suppose after this S prime reaches over here. After this S prime reaches over here, suppose the acceleration changes. Okay, so a naught value is 2 meter per second square over here, and now the a naught value over here is suppose 3.2 meter per second square. Then such a situation is called as a situation in which acceleration is not constant. Okay, so such situation we are not assuming. We are assuming that the acceleration is a naught, and the a naught acceleration, if it is 2 meter per second square, then the throughout the motion it will be 2 meter per second square only. That's what we are assuming, so that we have convenience. Okay, so total force or equation of motion in a non-inertial frame, let us see. Now let x a is equal to acceleration of a particle in an inertial frame S. Okay, so suppose this is your inertial frame S, and a is acceleration of any body in the inertial frame S. Suppose we have a body, and its acceleration is what? It is given over here. A is suppose the acceleration with respect to is this is what? This is inertial frame, right? So this A is suppose the acceleration of this any body, point, object with respect to this inertial frame S. Okay, so acceleration of a particle in an inertial frame S. The inertial frame means in this case we are assuming what is inertial frame. Either it is moving with a constant velocity, or either it is stationary, right? Inertial frame means a frame which is either moving with a constant velocity, or either the frame is stationary. So such frames are called inertial frames, right? Now the real force acting on this particle with respect to this inertial frame, now as the real force will be the one which is acting in the inertial frame, right? Because in inertial frame the acceleration which you see is real. Okay, real life acceleration. In reality such a acceleration is there. In inertial frame whatever acceleration you observe, that is the real acceleration of the body. So the real force acting on the particle will be F vector equal to ma vector, right? This will be the real interaction, because a vector is the real acceleration. Okay, you can see in the figure over here that this a particle, as it is moving to the right side with constant acceleration a, it is with respect to this inertial frame S. Okay, so such is the situation. So the real acceleration is your a, and real force acting on the particle will be F vector equal to ma vector. That is your real interaction. Okay, in non-inertial frame S prime, the particle will appear to be acted upon by pseudo force. What will happen in a non-inertial frame S prime? Let us see the same object in the non-inertial frame S prime. So in this particular non-inertial frame S prime, as already derived in the previous class, minus ma naught force will be acting on this particular object with respect to this frame. Let me show the non-inertial frame with a green color. So I have shown the non-inertial frame with a green color over here. Okay, let us show it with blue color because I think green color is not properly visible. So let us show it with blue color. So S prime is the non-inertial frame which I have shown with a blue color. Now you know this very well that minus ma naught, okay, is the pseudo force acting on any particle with respect to this frame, a non-inertial frame. We have already found out that in order to apply equation of motion in a non-inertial frame, we have to adjust the equation of motion with pseudo force, so that we can apply the equation of motion in a non-inertial frame. Okay, in order to write the Newton laws correctly in a non-inertial frame, we actually in order to apply Newton's laws in non-inertial frame accurately, we have to take into account the pseudo force also, right? So minus ma naught is the pseudo force. So this is your real interaction, and in a non-inertial frame S prime, the particle will appear to be acted upon by a pseudo force F naught vector equal to minus ma naught vector. Okay, so in this particular non-inertial frame S prime, the particle will be acted upon by pseudo force as already told to you and already derived in the previous lecture as well. Okay, so the total force observed in S prime will be F prime vector equal to F vector plus F naught vector. Now this is the real force plus this pseudo force, that will be the total force observed in this non-inertial frame S prime. Okay, so F prime, the force acting in non-inertial frame S prime, that will be equal to F plus F naught. Okay, F means the real interaction and F naught means the pseudo interaction. So after you add these two interactions, you will get the resultant force, okay, which is observed from S prime. This is not a real force observed. Okay, F prime is not a real force, it is the force which is being observed from S prime. Real force is only that which is observed from inertial frame. Okay, real force is only that force which is seen from the inertial frame perspective, but whatever force is seen from the non-inertial frame perspective, that force is not real. That is actually a combination of real and pseudo force. Okay, so you have to actually add real force, that is force with respect to inertial frame, and you have to add pseudo force also in it. Then you get the force with respect to non-inertial frame. So F prime is the force with respect to non-inertial frame, and ma vector plus minus ma naught vector, that is what is the force observed from S prime frame. Okay, if a prime equal to acceleration of the particle in frame S prime. Okay, so if a prime is suppose this is the acceleration which is observed from the frame S prime, then what will be the equation of motion? This particular resultant force F prime can be shown as ma prime, right? Because a prime is the acceleration with respect to that accelerated frame S prime, okay, which is non-inertial. So F prime equal to ma prime, right? So you can replace F prime with ma prime. So you replaced F prime with ma prime over here, and this F, it is as it is. Okay, we have written it deliberately as it is, and this F naught, okay, that is replaced by minus ma naught. So we have written over here. So this is suppose your equation number 2. Okay, so we can write one equation from here, that real force plus pseudo force equal to, what is this? Real force. Okay, so you can see the real force over here plus pseudo force, you can see the pseudo force over here, equal to what? Equal to mass, okay, multiplied by acceleration with respect to non-inertial frame, acceleration with respect to non-inertial frame. So you can write one formula clearly from here, that real force plus pseudo force equal to mass into acceleration with respect to non-inertial frame. Quite a common sense thing. Okay, and this is suppose your equation number 2. Then what happens? This is the equation of motion which you have, okay, with you. Okay, so this is the equation of motion which you have with you. Okay, just a second friends, just a second, let me have some water, then we will return. Let's begin once again. Okay, so we have already seen that real force plus pseudo force equal to mass into acceleration with respect to a non-inertial frame. So hopefully the recording is also in the on mode. Sure. Now let us see motion in rotating frame, that is your Coriolis force. You can also write it over here, that this F, what is it? This F is your ma. You can write that also over here. Okay, you can write ma vector also over here if you want. Okay, and you can cancel out the m also from both the sides, and you can write that your a vector minus a naught vector is equal to your a prime vector. Okay, now what is this a naught? A naught is the acceleration of the non-inertial frame. Okay, this is acceleration of non-inertial frame, and this is the acceleration of the body with respect to inertial frame. Okay, and this is what resultant acceleration, right? This is the resultant acceleration with respect to non-inertial frame. So you can write the formula that you can write one formula over here as follows. The formula which says something as follows, that A, okay, minus A naught is equal to A vector, okay, is equal to your A prime vector. So what is this formula telling you? That what is your A? A is your acceleration of body with respect to inertial frame. Okay, acceleration of body with respect to inertial frame. Okay, now what is your A naught? Clearly your A naught is acceleration of non inertial frame. Acceleration of non inertial frame with respect to what? Inertial frame. Okay, and your A prime is the acceleration observed from non-inertial frame. Okay, acceleration observed from non-inertial frame. So A is acceleration of body with respect to inertial frame, A naught acceleration of non-inertial frame with respect to inertial frame, and A prime is the acceleration observed from non-inertial frame. Now you know this very well that we had the diagram as shown in the previous slides. Okay, this particular diagram you can see. So in this particular diagram, okay, in this particular diagram, if suppose this object itself is moving with the acceleration A to the right hand side, then what will happen? This A acceleration has been taken with respect to inertial frame S. This A naught acceleration has also been taken with respect to this inertial frame S. Okay, and the A prime acceleration which will be observed from S prime. Okay, A prime will be the acceleration of this body. This body will have acceleration A prime with respect to this frame S prime. So hopefully you got each and every term which I was trying to tell you. Okay, so that is a very easy concept, right? So these are the concepts which you must take care of. Okay, so let's move on. Motion in rotating frame, that is your Coriolis force, right? Motion in rotating frame, that is your Coriolis force. The concept of Coriolis force we will learn over here. In the geography GS also you many a times see the Coriolis force. Okay, many a times in geography GS also many educators, many teachers keep on telling you about the Coriolis force. But what is this Coriolis force actually? We are going to see this Coriolis force. What does it mean in reality? So this is your point O, suppose. So what will happen from this point O? Okay, this x-axis is over here, this y-axis is over here in the 2D plane, but your z-axis, that is coming out of the plane towards your face. Okay, it is z-axis is coming out of this particular point outwards. It is coming out of this particular point outwards towards your face. Okay, so that is the thing. So z-axis is out of the plane over here. Okay, perpendicular to your mobile screen. This particular axis is coming out of the plane of the laptop towards your face. Okay, and this particular z prime is also coming out of the plane of the laptop towards your face. But this x prime and y prime, these are on the plane of your laptop. This x and this y, they are on the plane of your laptop. So motion in rotating frame, Coriolis force. Now this particular point P we have taken over here, and this particular point P has what kind of you can say, you can see over here, this particular point P has the coordinates. What kind of coordinates? You have to visualize now. This particular point P with respect, now suppose this is your frame S, okay, this is what your frame S, this is your frame S, this is what your frame S, okay, this is your frame S. Now S prime, what about S prime? S prime, what are your frames S prime? So you can see this is your frame S prime, okay, and this is your frame S prime, okay, and this is your frame S prime. I think the brightness is so high that the green colors are not at all visible, okay, so I will try to make slide of a different color from the next time onwards, but anyways, for the time being you can understand this. So if I want to take the coordinates, okay, if I want to take the coordinates, when you take the coordinates in 2 dimension, then what happen? Then in 2 dimensional you get the x coordinate and you get the y coordinate from here, okay. So now it is 3 dimensional, so what will happen? You will also have a z coordinate, okay, you will also have a z coordinate. So z coordinate is out of the plane, so the point at which this will make the 90-degree angle with the z axis, okay, that will be your z coordinate. So assume that this is coming out of the plane, okay. So these are the conditions. So this is what, this is 90-degree angle over here. Now similarly you must be knowing the concept of coordinates, right? So the same point P will have coordinates x prime, okay, it will be perpendicular to this, then y prime. How will you take the components y prime? So like this, okay, perpendicular to this, then z prime, in order to take z prime you will take such a line, and over here it will be 90-degree, okay. So such is the thing. So this point P has 2 coordinates with respect to different frames. With respect to frame S, it has coordinates x, y, z with respect to frame S, and with respect to frame S prime, which I have marked with green color, it has coordinates x prime, y prime, z prime. Why? You must be knowing, right? You know this very well, how to take coordinates, okay, you know how to take coordinates very well. You must have learned from your lower class itself, okay. So how did you take the coordinates in the lower classes? You did something like this, okay. Suppose this is your x, y, okay. So how did you take it? This is suppose your x axis, this is suppose your y axis, and over here some point P is there, okay. So how do you take its coordinates? So you go this much distance over here, so this is your x suppose, and this much distance you go in the y direction, so this is your y suppose. So then you say that this particular point has the coordinates x comma y, right? Like this you call it. So similarly over here also we have given it the coordinates, but it is in 3 dimensional, so we will also have to take with respect to the perpendicular axis also, which is the z axis, which is coming out of the plane. So this particular point P has x, y, z coordinates with respect to this S frame, and the x prime, y prime, z prime coordinates with respect to this frame S prime, and this frame S prime is rotating with a angular velocity omega, right? Just remember this, that this frame S prime is moving, it is rotating about which axis? About this z prime axis, okay, means z axis. So about this z axis, this particular axis which is coming out of the plane, about that axis, this it is rotating, this x prime, y prime frame, that is the S prime frame, is rotating with an angular velocity omega, okay. In which direction? This is the direction of rotation, that is your anti-clockwise, okay. This is the direction of rotation, that is your anti-clockwise direction. Now whenever the direction of rotation is anti-clockwise, what is the direction of omega? Whenever direction of rotation is anti-clockwise, what is the direction of omega? Omega means I am talking about this omega vector. What is the direction of this omega vector? Whenever your frame rotates in an anti-clockwise direction. So it is very easy to find out. The direction of this omega can be found out using the right hand thumb rule, okay. What is right hand thumb rule? You should keep your fingers like this, okay. You should keep your fingers like this, and the direction in which your thumb will point, okay. Your fingers must, your nails of your fingers must be in this direction, and your fingers must go like this, okay. So nails of your fingers must be in this direction in which the arrow is pointing. So nails of your right finger should be in this particular direction, and your hand should be curled. your finger should be curled in this particular manner, and your nails of the finger should be in this particular direction. Okay, and the direction in which your right hand thumb will point in this condition, that will be out of the plane. Okay, that will be what? That will be out of the plane. So you show it like this. So that will be out of the plane. So the direction of this omega vector is going to be out of the plane, and as it is a anti-clockwise motion, right? As it is anti-clockwise motion, this particular motion, okay, this particular motion, as it is anti-clockwise motion, so by right hand thumb rule, your direction of omega vector will be out of the plane. And suppose if it would have rotated like this, then what would have happened? Then the direction of omega vector would have been inward, inside the plane. Why inside the plane? Because in this particular situation, when it will rotate in the clockwise sense, then your direction of nails, okay, keep your direction of finger in such a manner that the nails of your right hand finger point in this particular arrow direction. So your nails like this, okay, your nails like this, and your fingers like this. Then your thumb will go inside the plane of the laptop. Okay, so such is the thing. So such kind of a situation is there for clockwise direction. So by right hand thumb rule, you can certainly find out the direction of this omega vector in this particular case. Okay, then r is your what? R is your x I cap plus y j cap plus z k cap. So this is your r vector. Now this r vector, as the origin of these two coordinate axes, that is s prime axis, s prime frame and s frame. Okay, s prime frame and s frame both have the same origin O. Okay, so with respect to this origin O, the vector r is common for both these frames. Okay, for s prime frame also r vector is there, and for s frame also r vector is there. Okay, so the vector is common because the origin of the two frames is common. Okay, and origin is not changing for any of the frames. Now this r vector has a position x I cap plus y j cap plus z k cap with respect to this s, because in the direction of this x it will be I cap direction over here. Okay, over here it will be j cap direction, over here it will be k cap direction. Okay, right? And similarly, if I want to find the direction along this, then what will happen? If I want to find out the direction along this, will be I dash cap. Okay, the direction along this will be j dash cap. Okay, and the direction along this will be k dash cap. Okay, right? So such is the situation. So you must remember this thing. So r x I cap plus y j cap plus z k cap, r x prime I prime cap plus y prime j prime cap plus z prime k prime cap. Okay, so this is suppose your equation number 1. This equation 1 is with respect to this s prime frame. Okay, right? With respect to this s prime frame, this is the equation number 1 which you have over here. Now tell me one thing, that which of these vectors will be constant. Okay, whether this will be constant or this will be constant, this will be constant or this will be constant or this will be constant, or which of these vectors will be constant. So let me tell you that this frame is stationary, right? This particular frame S, this frame S is stationary. So as this frame S is stationary, so clearly these three vectors I cap, j cap and k cap, they will have the same direction always, right? So these three vectors will be constant. But these three vectors which are along here, okay, along here it is I cap vector, along here it is j cap vector, along here it is k cap vector. These three vectors will not be constant. Why? Because although the magnitude will be equal to 1 and a constant, but the direction will keep on changing because the frame s prime will rotate. So after rotation for some time, what will happen? After rotation for some time, this s prime frame will reach over here. Okay, this s prime frame will reach over here, and what will happen? This particular y prime axis will go over here. Okay, this particular z prime axis, okay, it will remain at the same place because it is coming out of the plane and it is rotating along the z prime. So z prime will remain as it is. So leave that. But if z prime also rotates, then what will happen? This is your x prime, right? So the direction of I cap prime, okay, direction of j cap prime, okay, direction of k cap prime, the directions of these three vectors will keep on changing because the frame is rotating. It will come over here, then it will come over here, then it will come over here. Okay, so the frame is rotating, so the direction of vectors I prime, j prime, k prime, the direction of all these vectors is changing. Okay, so I cap prime, j cap prime and k cap prime, these will be non-constant vectors, whereas I cap, j cap, k cap will be constant vectors. I cap, j cap, k cap will be constant vectors, whereas I cap prime, j cap prime and k cap prime will be non-constant vectors because their direction is continuously changing, right? So suppose this is your suppose equation number 1. This cap equation is suppose your equation number 1. Then what happens? Differentiate equation 1 with respect to t. So you have to differentiate this equation 1 with respect to t. Then what will happen? Clearly you will apply the UV rule, right? dr by dt. So you will apply the UV rule. Then what will happen? UV rule, after you apply, then UV rule applied over here. First differentiation of this remains as it is. Then differentiation of this remains as it is. Okay, then differentiation of this remains as it is. Then differentiation of this remains as it is. Then differentiation of this remains as it is. Then the differentiation of this remains as it is. Okay, so you apply the UV rule, right? So after you apply the UV rule, what does it say? UV rule says, UV rule clearly suggests, UV rule, what does it say? d by dt of uv, that is equal to u dv by dt plus v du by dt. That's what is your UV rule, right? So you will apply the UV rule over here. So after you apply the UV rule, what do you get? The expression which you get after applying UV rule over this equation 1, the expression which you get is something like this. Okay, you can check the term by term. After I applied d by dt, okay, d by dt of x prime I cap prime, okay, plus d by dt of y prime j cap prime, okay, plus d by dt of what? Z prime k cap prime. Okay, after I apply these, then what will happen? After I differentiate this, I get these two terms, okay, by UV formula. After I differentiate this particular thing, I get these two terms, okay, by UV formula. And after I differentiate this particular term, then I get this particular term and this particular term. Okay, so that's how you will differentiate equation number 1 by using the UV formula. So I showed it successfully to you, that how we have differentiated. So this is your what? This is your equation number 2, suppose. Now dr by dt equal to your v, that is velocity of the particle relative to inertial frame s. So dr by dt equal to v vector, dr vector by dt, that is equal to your v vector, velocity of the particle relative to the inertial frame s, right? As this r vector as it is relative to this s frame also and s prime frame also, both of them have the same vector r only, because the origin of these two frames being the same, that's why the vector r for both these two frames will be the same, right? So whether I write dr by dt, it is with respect to this s frame only, okay, because the s prime frame is continuously moving, right? And the r vector is from s frame only, s frame also and s prime also. So if I write dr by dt, then I will consider it to be with respect to s prime, so that my calculations go easier. Okay, so dr by dt, let us consider it to be equal to v vector, because rate of change of displacement, and this is what? This is your displacement, right? Shortest possible distance, and shortest possible distance from the origin, that is your vector connecting the point and the origin, straight line connecting them, that is kind of your displacement. Okay, now rate of change of displacement is equal to velocity, so rate of change of displacement will be equal to your velocity. So velocity of the particle relative to the inertial frame s. So this is what? This is velocity, dr by dt will be velocity of this particular point p with respect to this particular frame s, because with respect to s prime the things will keep on changing. Okay, so we are not considering it to be with respect to s prime. we are considering it to be with respect to s, so that we can establish a relation between s prime and s. Okay, although the dr by dt will also be with respect to s prime also. Okay, but as s prime is rotating, that's why we are not considering that. So v, that is linear velocity, okay, not angular. This is linear velocity. So linear velocity of the particle relative to the inertial frame s. Now this particular term, if you observe these particular terms, these three initial terms over here, then what will happen? This dx prime by dt, what is it equal to? It is rate of change of x coordinate, right? Dx prime by dt is what? Rate of change of x coordinate of what? S prime frame. Okay, let us see over here. Let us see dx prime by dt, what will it be? So this is your x prime. Okay, so dx prime by dt, what will it be equal to? That will be equal to the rate of change of x coordinate with respect to s prime frame, right? Rate of change of x coordinate with respect to s prime frame. Okay, and what will be your y prime? dy prime by dt, what will it be equal to? That will be rate of change of y coordinate, that is y prime coordinate with respect to s prime frame, right? And rate of change of z prime coordinate with respect to s prime frame, that will be dz prime by dt. Okay, because these coordinates will keep on changing, right? Because x prime is the distance from here, y prime is the distance from here, right? And z prime is the distance from this particular axis. So this is z prime, right? And as the frame is rotating like this, so this x prime, y prime and z prime will change with time. So there will be some value of associated with these changes. So rate of change of x prime, that will be dx prime by dt. Rate of change of y prime, that will be dy prime by dt. The rate of change of z prime, that will be dz prime by dt. So those will be your component of velocity along x direction, component of velocity along y direction, and component of velocity along z direction, right? So clearly you can see over here that this particular term will be equal to, because it is rate of change of displacement in x direction with respect to s prime frame. Okay, rate of change of displacement in x direction with respect to s prime frame. So that will be equal to velocity along the x direction. Okay, rate of change of displacement is equal to velocity. So that's why vx prime dy prime by dt, the vy prime, because along the y direction means yz direction, then dz prime by dt along the z dash direction with respect to s prime frame. So vz prime by vz prime, okay, dz prime by dt equal to vz prime. Now vx prime I cap, vy prime j cap, and vz prime k cap, what is it? That is equal to v prime vector, that is velocity of the particle relative to rotating frame s prime. Okay, v prime vector, what is it? That is your velocity of particle with respect to rotating frame s prime, right? You can clearly see this thing from the coordinates, right? You can clearly see this thing from the coordinates, because the coordinates over here are x prime, the coordinates over here are y prime, and the coordinates over here, okay, these are your z prime. So you can clearly see that when we take the rate of change of this, what will happen? The velocity of this particular point with respect to this x direction, right? So all these things are there. So you can clearly, certainly you can see all these things. So this is the velocity of particle relative to rotating frame s prime. This is quite a common sense thing. Now since unit vectors I cap, j cap, k cap prime, okay, I cap prime, j cap prime, k cap prime, these unit vectors are rotating. As these unit vectors are rotating, so this particular term, and this particular term will not be equal to 0. Why it will not be equal to 0? Because these particular three axes, that is I cap is along this, j cap is along this, and k cap is along this. So these three axes are basically rotating, right? So since unit vectors I cap prime, j cap prime, k cap prime are rotating with angular velocity omega, so what will happen? Then d, now over here one vector sign is missing, I am really sorry for that. Okay, one vector sign must be there over here. Okay, so since unit vectors I cap prime, j cap prime, k cap prime are rotating with angular velocity omega, so what will happen? you can clearly see that omega cross I cap, that will be equal to d I cap prime by dt, d j cap prime by dt will be equal to omega cross j cap, and d k prime by dt will be equal to omega cross k cap. Okay, k prime cap. Why will it be like this? Because you know this very well from this particular relation, that v equal to dr vector by dt equal to omega cross r vector, right? This relation you must be knowing from the very beginning. This is even taught in the elementary physics 11th standard book also. You will find the derivation for this. Omega vector cross r vector equal to v vector, and v vector equal to dr vector by dt. So this particular relation, from this particular relation only we have done this. In the place of r we have substituted I cap prime, in the place of r we have substituted j cap prime, in the place of r we have substituted k cap prime. Okay, so from this particular relation only we have got these three relations. So now the equation 2, how can it be written? This particular equation 2, as you can see over here, that these initial three terms, okay, these initial three terms, they can be replaced by this particular term, okay, by this particular term, and the last three terms, they can also be replaced by a particular term which is like this. Okay, so you replaced, after you replaced all these, equation 2 becomes like this. Okay, equation 2 becomes like this. So let me erase these things, okay, so that it becomes convenient for you to tell later on. So we have erased them very fast. Now just while making the notes, put a vector sign over here while making the notes, certainly. So equation 2 can be written like this, which I have shown over here. Now v equal to, over here also one vector sign is missing, put it over here. Okay, put this vector sign over here. So v prime vector plus omega vector cross r vector. You will certainly understand all this after you actually solve everything. Solve means copy down everything, and if you try to understand everything, you will be certainly clear with all these things. Now y x prime I cap prime, y prime j cap prime, z prime k cap prime. Why these have been written as r vector? Because the origin of these two, okay, because the origin of these two frames, s prime and s frame, the origin of these two frames is same. As the origin is same, so this vector r will be the same for both these frames. Okay, the vector r will be same for both these frames, s and s prime. So that's why you have already seen this, that r equal to x I cap, y j cap, z k cap, and r equal to x prime I cap prime, y prime j cap prime, z prime k cap prime. So taking the help of this equation 1, what have I done? I have replaced this particular term by r vector in order to simplify our result. Okay, and how we got this I have already told to you just some time ago. So v vector equal to v prime vector plus omega vector cross r vector. This is what is your equation A. Now equation A can be written as, how can it be written? Like this. Okay, you can replace the v, you can replace this particular v by dr by dt, and this particular term v prime by d dash r by dt. Okay, so what is the difference between these two? What is the difference? Let me write it properly over here. This is your vector sign. Okay, now what is the difference between this particular term and this particular term? Let us see. Let us understand the meaning of this dr by dr vector by dt and d dash r vector by dt. Now you must understand this thing, that your r vector, okay, your r vector, the resulting value is the same. Okay, the resulting value of the r vector is the same for both these frames, s frame also and s prime frame also. The value of r vector is same. But when you take the differentiation of this r vector, when you take the differentiation of this r vector, that will be your velocity. Okay, when you take this differentiation of this, it will be velocity with respect to s frame. When you take differentiation of this, it will be velocity with respect to s prime frame, right? But you know this very well, that if I denote the both of these by d by dt of r, and suppose I denote this also by d of dt of r only, then these two will be the same terms. But we know this very well, that s prime is a rotating frame, so the velocity v prime must be different with respect to this s prime frame as it is rotating. That's why in order to show the different value of differentiation, we are actually denoting one differential symbol by dr by dt and another differential symbol with respect to s prime frame by d dash r by dt. Okay, so that is the thing. So this is your equation B. This relation holds good for other similar vectors which may be expressed as an operator equation also. So this particular relation holds good for similar other vectors also. And when I convert it into the operator equation, it looks something like this, that differentiation with respect to time in S frame. What is this? Differentiation with respect to time in S frame. This is differentiation with respect to time in S prime frame. Okay, and this is omega vector cross blank, means you can put any vector over here, so that it will hold for any vector. Okay, it will hold good for any vector, not just r, any vector. So this relation holds good for other similar vectors which may be expressed as an operator equation, which is shown over here. So we can write like this. Okay, in the place of these blank operators we will put velocity vector. So we can write d by dt v vector equal to d prime by dt v vector omega cross v vector. Okay, now you must understand this thing. Let me see over here. Okay, yes. So when we put the v vector, it is like this, and in the place of v you can certainly put dr by dt, and in the place of this v also, okay, as we have put v all everywhere. So in the place of this v dr by dt, in the place of this v also dr by dt you can substitute, this v also dr by dt you can substitute, but certainly you should not substitute dash over here. Okay, why should not be dash over here? Why it should not be d dash r by dt over here? Because we are substituting v vector. Which v vector is this? This v vector is with respect to the frame S. Okay, this v vector is with respect to the frame S. So that's why dr by dt will come over here, not d dash r by dt. Okay, so you must remember this thing. So d by dt dr by dt plus d prime by dt dr by dt plus omega cross dr by dt. Now this particular term d by dt dr by dt, that will become d2 r by dt2. Okay, the d dash by dt dr by dt. Now we will substitute dr by dt from here, that is equation B. Over here we have substituted. Okay, and omega cross, in the place of dr by dt also we substituted in the terms of dash. So we substituted this particular term over here. Why are we doing all these things? In order to find the acceleration, because d2r by dt2 will be your acceleration, right? So we are finding the acceleration, that's why we are doing all these things. So after you apply the formulas, this will go with this, it will become double differentiation. This will go with this, it will become UV rule. Okay, this cross will go with this, will remain as it is. This cross will go with this. So what will happen? Okay, now let me bring this to the downward side. Okay, so let me move this to the downward side. Yes. So certainly there is some problem over here. Okay, certainly there is. Okay, so we have done all these things, right? Now these steps also you can understand. These are just UV rule we have applied, and we have opened the bracket. That's it. We have done nothing new. This particular term, it has appeared twice, so it will be 2 times. This particular term will remain as it is, and this particular term will remain as it is in the last. Okay, so this is suppose your equation number 3. So what happens is that d2r by dt2 equal to dv by dt equal to a, acceleration of particle in inertial frame S, d prime 2r by dt2. Okay, that is a prime, acceleration of particle in rotating frame S prime, and your okay, and your d omega by dt equal to d prime omega by dt plus omega cross omega. How we have found out this? Okay, how we have found out this? D omega by dt equal to this much. We have basically substituted omega over here. Just substitute omega over here. What will happen? D omega by dt equal to d prime omega by dt plus omega cross omega in this particular equation. Okay, operator equation. When I substitute omega over there, so I get d omega by dt equal to d prime omega by dt. That is, if you differentiate, okay, if you differentiate omega vector with respect to time in s frame, that is equal to differentiation of the omega vector with respect to time in s prime frame. So whether you take the differentiation of omega vector with respect to time in s frame, or whether you take the differentiation of omega vector with respect to time in s prime frame, both of the things are going to be the same. Okay, so that's what is meant by this, right? So all these terms are self-explanatory. So from this equation 3, what will happen? In the place of this d prime omega by dt, you can substitute d omega by dt over here, right? So just substitute that. So you will get like this: a equal to a prime 2 omega cross b prime. Okay, so we have basically substituted d prime r by dt to be equal to b prime, right? So we have substituted that. Then omega cross r, that is remained as it is. d prime omega by dt was there, so d prime omega by dt is equal to d omega by dt. So we have substituted d prime omega by dt by d omega by dt. So over here we got d omega by dt. Cross r has remained as it is, this particular term. Then this a prime vector d prime to r by dt2, that is your a prime, okay, acceleration with respect to s prime frame. And this particular thing d2 r by dt2, this is what? This is acceleration with respect to the frame s. So d2 r by dt2 is acceleration with respect to frame s. Okay, so we have substituted all these terms. So you got equation C basically. The term 2 omega cross v prime vector, 2 omega vector cross v prime vector, is known as Coriolis acceleration. Now you must remember all these terms. You know this very well from the 11th standard units and dimension. Okay, from class 11th units and dimension chapter, you have learnt one thing very well, that only quantities with the similar units, quantities with the similar dimensions can be added. Only those quantities can be added. So in the left hand side of this equation there is acceleration, right? So meter per second square is there in the left hand side. Then over here also meter per second square is there. Okay, so this particular term will also be meter per second square because it is being added to quantity which has meter per second as square as the unit. This particular term must also have meter per second square as the unit, and this particular quantity must also have the same dimensions. Why? Because only then these 4 terms can be added together. Only then the addition of these 4 terms will be defined. Only in that case. So that's why the term 2, that's why all these terms also denote some kind of acceleration. All these 3 terms also denote some kind of acceleration. So the term 2 omega cross v prime is known as Coriolis acceleration. Okay, this particular term 2 omega cross v prime is known as Coriolis acceleration. If v prime equal to 0, then what happens? If this v prime equal to 0, or if omega and v prime, these are anti-parallel, or if they are parallel, then what will happen? If parallel or anti-parallel or one of them is 0, then certainly this particular term Coriolis acceleration will be 0, right? So omega cannot be 0 because the frame is clearly rotating, right? So omega vector cannot be 0. So only thing is v prime can be 0. So if v prime is 0, then this particular term will be 0. If both of them are parallel, then what will happen? Sine 0 will come. If both of them are parallel, then sine 0 will come, okay, in the cross product. So as sine 0 will come in the expansion of sine product, so that will be equal to your in the expansion of cross product as sine term will come. So that will be your clearly 0 if they are parallel. And if they are anti-parallel, then sine 180 will come in this particular expression when you expand this cross product, right? Sine 180 will come. So that will also be 0. So this 0, this 0, this 0. So that's why this term 2 omega cross v prime is known as Coriolis acceleration, and it is equal to your 0. So this particular term is your equal to 0, right? In these particular cases, so Coriolis acceleration is 0 if v prime is 0. Coriolis acceleration is 0. Coriolis acceleration is 0 if omega vector and v prime vector are parallel. Coriolis acceleration is 0 if omega vector and v prime vector are anti-parallel. So in these 3 situations, Coriolis acceleration is 0. The term omega cross r is called as centripetal acceleration. Okay, this is what this particular term omega cross r is your centripetal acceleration, and this d omega vector by dt cross r is the acceleration when omega equal to omega t. Okay, what is this? It is the acceleration when omega, that is your this particular acceleration, if suppose your frame is rotating with a constant angular velocity, if suppose your frame is rotating with a constant angular velocity, then what will happen? This particular term will be 0 if your frame is rotating with a constant angular velocity. Just like earth, if your frame is rotating with a constant angular velocity, then this particular term will be 0. Why? Because omega vector will be constant in that case, in the case when your rotation, that is your angular velocity, is constant. In that case, just like earth, the angular velocity of earth is constant. Why? Because the earth completes one rotation around itself, in 24 hours, right? So that's why the angular velocity of the earth is equal to constant, and as the angular velocity of earth is constant, this particular term will vanish in case of earth, because d omega by dt for earth will be a constant, right? So d omega by dt cross r is the acceleration when omega, this acceleration only exists when your angular velocity omega is a function of time. Okay, because only then this term will be non-zero. But if the angular velocity omega with which the frame is rotating, that is constant, then this particular term will be, omega vector will be constant, and this particular term will vanish. So 0 cross r vector, so that will be equal to 0. So this particular term will vanish. So in case of earth, because the earth completes one rotation around itself in 24 hours only, so the angular velocity of earth is constant, and as the angular velocity of earth is constant, so d omega by dt term will vanish in case of earth. So this third term will vanish in case of earth problems. Okay, so that is the thing. This is your equation C. Okay, so equation of motion in rotating frame from equation C, what do you get? Equation of motion in rotating frame from equation C, you get something like this. Okay, like this. Equation of motion, what you have to do in case of equation of motion? You have to multiply both sides by m. Okay, because you write the equation of motion in terms of what? Force, right? You write the equation of motion in terms of force, right? So you just multiply both the sides with mass, because mass into acceleration will become force eventually. So multiply both sides of this equation by mass. So let us multiply. What will happen? m a vector plus m a prime vector 2m. Okay, we have multiplied both sides of this particular vector with m. Okay, so we multiplied with m. So when we took the ma prime to one side and this term and these terms to the one side, okay, so these three terms have been taken to the left hand side. Okay, have been taken to the left hand side, though they became all minus now. So these three terms became minus. So ma prime vector equal to ma minus 2m omega cross v prime minus m omega cross r minus m d omega by dt cross r. So you can write ma prime as f prime force, right? In your force with respect to s prime frame. This is force with respect to s frame. Okay, so this is the force with respect to non-inertial frame. This is the force with respect to inertial frame, right? And this is what? This will be equal to your pseudo force. Okay, so F equal to we have already derived this equation. You can equate it from the previous class equation, right? You can surely relate this equation. We have already derived it over here, right? Over here we have already derived the relation. So after we find the equation of motion over there, we can compare it with this particular equation, which we have already found out in the previous, not previous means the previous segment of this particular video only. Okay, so what is there? The term 2 omega cross v prime is known as, all these things are over. So f prime vector equal to f plus f naught vector. Your f equal to m a vector, real or true force. F prime vector equal to effective force on m in s prime frame. F naught is fictitious force acting in rotating non-inertial frame, right? So you can certainly see that this particular term, okay, this whole term is your fictitious force. Okay, if you compare that equation with this, so this particular term is your fictitious force. So F naught will be equal to this particular term. Okay, these three terms. So F naught equal to this much. So your fictitious force in case of a rotating frame, fictitious force acting in case of a rotating frame will be this much. Okay, so if omega equal to constant, then this particular term will vanish and this particular term will remain. So in case of Earth, omega is constant, right? Angular velocity of Earth is constant because Earth completes one rotation around itself in 24 hours only. So the angular velocity of Earth is constant. So omega for Earth will be constant. So this particular term will vanish from this particular equation. So as this particular term will vanish from this particular equation, only two terms will remain. And as only two terms will remain, only these two terms will remain. And up to here only we can have this, okay, in case of Earth. So we have this particular expression, that is your equation 6, okay. So let me erase all these things. Yes. So 52's force equal to, this was your Coriolis force, we have already seen, okay. This is your centrifugal force, so we have written centrifugal force over there. This is what your Coriolis force, so we have written Coriolis force over there, right? So your 52's force is like this. Now your Coriolis force Fc equal to minus 2m omega cross v prime equal to 2m. You can expand the things, okay. You can certainly expand the thing. So your Coriolis force Fc, we are denoting it by Fc, that is equal to minus 2m omega cross v prime. Now omega cross v prime will be equal to what? Omega v prime sine theta n cap. What is this n cap? N cap is a vector which is found with the help of right hand screw rule. Right hand screw rule. So you, with the help of right hand screw rule, you can find out certainly that this n cap direction can be found out with the help of that right hand screw rule, but we will not go into all those details right now. So Fc is perpendicular to omega vector, right? Then Fc is perpendicular to v prime vector. Then what will happen? Certainly these are parallels because this is a cross product, right? So in the cross product, whenever you find the cross product of two vectors, what happens? The resulting direction is perpendicular to both those vectors. So the resulting direction of the product of cross product of these two vectors, the resulting direction of cross product of these two vectors will be perpendicular to both these vectors. You must know this, that there is a vector, suppose omega like this, and there is a vector v prime vector like this. Then how will you find the direction of cross product of these two? It is omega cross v prime, right? Omega cross v prime. So you will move from here to here while taking the cross product. So just curl your right hand fingers. Curl the finger of your right hands in this particular direction, so that the nails of your fingers are in the direction of arrow. Nails of your fingers of the right hand, nails of the fingers of your right hand are in this particular direction. So what will happen? That particular direction, in that direction your fingers will be curled with the nails of your finger towards the arrow, and the inside direction will be your direction of thumb. So the direction of cross product of these two vectors will be inside the plane. But if I want to find out v prime cross omega vector, if I want to find out v prime cross omega vector, then we will move like this, right? Because v prime is over here and omega is over here, so we will move in the opposite direction. In that case, the nails of your right hand fingers nails will be in this particular arrow direction, so the thumb will be out of the plane in that case. So that is the thing. That's how, with the help of right hand thumb rule or right hand screw rule, you can basically find out. So the direction of any particular when we take the cross product of any two vectors, the resulting direction is always perpendicular to both those vectors, okay. Resulting direction is always perpendicular to the plane consisting of both these vectors, right? So your Fc will be clearly perpendicular to omega vector, and your Fc will also be perpendicular to v prime vector clearly, because this n cap direction will be perpendicular to both these omega vector and v prime vector, and this as this n cap direction is the same as the direction of Fc vector, that's why. So Fc vector equal to 0, when will Fc vector will be equal to 0? When v prime vector equal to 0. So when v prime vector equal to 0, this particular vector v prime vector equal to 0, or when both of these are parallel or anti-parallel, depending on the angle, okay. So in order to have this Fc equal to 0, what will happen? This cannot be 0, omega cannot be 0, because it is, we have already considered the case that it is a rotating frame, already we have considered. So that's why omega cannot be 0 over here. So only thing which can be 0 is your v prime can be 0. So if v prime is either equal to 0, or either this angle turns out to be 0 or 180, that is the parallel and anti-parallel case, in that case your Fc will be equal to 0, right? So we have written over here that Fc equal to 0, Fc vector equal to 0 when either this particular term v prime equal to 0, because omega cannot be 0, so either v prime equal to 0, then Fc will be equal to 0, then either omega is parallel to v prime. In that case, theta will be equal to 0. So sine 0 will be equal to 0. This term will vanish. That is fc will be equal to 0. And when omega and v prime are anti-parallel, sine theta that will be equal to sine 180. Sine 180 means equal to 0. So this particular term vanished. So fc will be equal to 0 in that case also. So fc vector equal to 0 when these three conditions exist. Right? So these are the things. If suppose your omega and v prime are perpendicular to each other, then what will happen? Theta will be equal to 90 degree in that case. Theta equal to 90 and sine 90 equal to 1, right? Sine 90 equal to 1 in that case. So fc will be equal to maximum in that case, because sine can have a maximum value of 1, and that maximum value of 1 occurs when theta equal to 90 degree, right? So fc max will be equal to your minus 2m omega v prime. Okay, when both these vectors omega and v prime vectors are perpendicular. Okay, omega and v prime vectors are perpendicular. So that is the thing. So fc max, that will be maximum. Centrifugal force, a pseudo force which acts when the particle is stationary in rotating frame. What is a centrifugal force? A pseudo force which acts when particle is stationary in the rotating frame. Suppose you are sitting in a merry-go-round. Okay, suppose this is your merry-go-round and you are sitting inside this. So you will experience a pseudo force. Why? Because this is rotating. Okay, this is rotating. This particular jhula, okay, of the mela, this particular jhula of the mela, that is your machine of the fair. This particular machine is rotating. Okay, and you are rotating, you yourself are rotating with this particular rotating frame. So you will experience a pseudo force because you are stationary with respect to this machine. With respect to this merry-go-round, you are stationary, right? With respect to this merry-go-round, you are stationary because you are rotating along with the merry-go-round. You are sitting inside it. So with respect to this merry-go-round, you are stationary. So you will experience a pseudo force. So it is written that a pseudo force is a force which acts. A pseudo force is a force which acts when particle is stationary in rotating frame. Like the way you sit in merry-go-round. When you sit in a merry-go-round, you are rotating along with the merry-go-round. So with respect to the merry-go-round, you are stationary because you are sitting inside the merry-go-round. So with respect to merry-go-round, you are stationary. But you will experience a pseudo force, centrifugal force. Why? Because you are a particle which is stationary with respect to rotating frame. You are a particle which is stationary in respect to rotating frame, right? So you will experience a pseudo force. But you are not stationary with respect to an inertial frame. With respect to a frame on the ground, you are not stationary, you are rotating. But with respect to the merry-go-round, you are stationary, right? So that is the thing. So pseudo force is a force which acts when particle is stationary in rotating frame. Okay. So it is F vector equal to minus m omega cross r, as already found out just some moments ago. Okay. Now numerically equal to centripetal force but oppositely directed. What is centripetal force? A person is standing on the ground. Okay. Suppose you have a thread with you. Okay, you have tied a stone over here. This is a stone. This is a what? Stone. And you are basically rotating this particular stone like this. Okay, around this particular point. Then what will happen? With respect to someone sitting on this stone, suppose an ant is sitting on this particular stone. Then what will happen? The ant will feel that I am facing a force in the opposite direction, that is away from the center. But with respect to a person standing on the ground, he will think that the ant is getting attracted towards the center. Okay, so with respect to an inertial frame, when a stone is rotating, the inertial frame person feels when a particular stone is rotating, the inertial frame person feels that the stone is getting attracted towards the center. And a non-inertial frame person, that is the person who is sitting on that stone, that is the ant in this case, that particular ant feels that the force is acting in the opposite direction, okay, away from the center, right? So because she is in the non-inertial frame, she is rotating along with the stone, so she will feel that the same force is acting in the centrifugal direction, that is opposite to center, and a person standing on the ground thinks that it is acting towards the center, right? So this particular centrifugal force is equal to minus m omega cross r, that is your centrifugal force. This is numerically equal to centripetal force. Okay, this is centrifugal force is what? The centrifugal force is numerically equal to centripetal force, but it is oppositely directed. The centripetal force will be seen with respect to inertial frame, right? The centripetal force will be seen with respect to what? Inertial frame. Okay, that is the stationary or frame moving with uniform velocity. So that particular inertial frame will see that this centripetal force is acting towards the center, okay, in case of a rotating body. And this centrifugal force will be seen by someone who is rotating along with this, sitting over here. So he or she will feel that this same magnitude force is acting in the opposite direction according to this sitting person. So that's the thing, that's what has been described over here. So it is numerically equal to centripetal force, but it is oppositely directed, so we denote it by the negative symbol, negative sign, okay. So we will do from here onwards, that is deviation suffered by a particle onwards, we will do in the next class. But remember this particular fact, that numerically equal to centripetal force, that is your centrifugal force is numerically equal to centripetal force, but it is opposite in direction. This fact you must remember, okay. So from here onwards we will do in the next class, that is deviation suffered by particle from the vertical when dropped from a height h. From here onwards we will do in the next class. So till then, keep yourself healthy and calm, and never get distracted by anything, okay. Never make your mood off, okay. So keep on doing your work without hesitating, without thinking about your capabilities, without giving it a thought that I can't do this or I can't do that. Do not think all this stuff, okay. So thank you very much.